Your quiz covers sections 3.5 and 3.6. We're to start looking at two questions that tell you to give the zeros given the one or first zero that they give you. For this one, you could do it one of two ways. You could either work with the I, or you could change the I to the square root of -1. It's up to you which method you use. I'm going to do it both ways so that way you see it, but again, it's totally different, or it's totally up to you the way that you do it. For number 1, you have f of x is equal to 2x to the 4th power plus x cubed plus 5x squared plus 9x minus 27. You're given that x is equal to -3i. I is an imaginary number, which means there is a conjugate to it. That means that this is not just the only zero or the only root that's given to you. You also have x is equal to positive 3i, because the conjugate of -3i is positive 3i. So you can work with both of these if you're going to keep the I, and you move the 3i over, and the x is equal to -3i by adding it to both sides. That gives you x plus 3i is equal to 0. For x is equal to positive 3i, subtract that 3i over, and that gives you x minus 3i is equal to 0. If you FOIL these out, you have x plus 3i times x minus 3i. So if we FOIL these out, you're going to have x squared minus 3i times x plus 3i times x minus 9i squared. You know that I squared is equal to -1, so we're going to change the sign in front of that negative, or that 9, to be a positive 9 instead of a -9, and cross out that I squared. The -3ix and the positive 3ix are opposites, so they cancel, and this is just x squared plus 9. That x squared plus 9 you're going to use with your polynomial, that f of x, with long division in order to solve for the other zeros. So that x plus 9 is going to go on the outside. Or sorry, it's x squared plus 9. So if it's x squared plus 9, you need the x, so we're going to add in a 0, x plus 9. That goes on the outside. On the inside, you're going to have the 2x to the 4th power plus x cubed plus 15x squared plus 9x minus 27. Use your long division. The x squared on the outside multiplies by 2x squared to give you the 2x to the 4th power that you have underneath. You're going to multiply that 2x squared by the 0x and the 9 as well. Put it underneath the x cubed and the 15x squared. 2x squared times 0x is 0x cubed. 2x squared times 9 is 18x squared. Subtract these. Distribute your sign. Change the sign on everything and start canceling out the first term. You have x cubed minus 0x cubed, which is just x cubed. Then 15x squared minus 18x squared is -3x squared. You need 3 terms to work with underneath, so because you have 3 terms on the outside, so that 9x drops down. From here, start all over. X squared from the outside multiplies by x to give you x cubed. X times 0x is 0x squared. X times 9 is 9x. From here, subtract. Distribute the sign. Change the sign on everything. You are left with -3x squared plus 0x. And again, you need 3 terms, so drop down that -27. And start all over again. The x squared on the outside multiplies by -3x, or sorry, -3 to give you -3x squared. From there, the -3 times 0x is 0x, and -3 times 9 is -27. Distribute your negative to subtract these. Change the sign on everything. Your 3x squareds cancel, your 0x's cancel, and your 27's cancel to give you 0 as your remainder. So now you have 2x squared plus x minus 3 that you have to solve. In order to solve this, you have to factor, and your a is something other than 1. So multiply your 2 by your negative 3, that gives you negative 6. Your factors of negative 6 that add up to 1 are negative 2 and positive 3. So we are going to rewrite this as 2x squared minus 2x plus 3x minus 3 is equal to 0. Factor this by grouping. Factor out a 2x from the first, a positive 3 from the second. That gives you 2x plus 3 times x minus 1 is equal to 0. If you set both of these equal to 0 and solve, you get that x is equal to negative 3 halves and x is equal to positive 1. So look at all of your solutions. Remember, you took the conjugate from the very beginning. You have x is equal to negative 3 halves, x is equal to 1, x is equal to negative 3i, and x is equal to positive 3i. So all 4 of those are solutions. For number 2, we're given g of x is equal to x cubed minus 11x squared plus 43x minus 65 with a given 0 of x is equal to 3 minus 2i. Again, remember, at the very end, because I'm going to turn this I into the square root of negative 1, you have to make sure you take care of the conjugate of this part. If we turn that I into a negative 1 and we don't work with the I, we're going to have x is equal to 3 minus 2 times the square root of negative 1. Again, this is just another method to use. So you're going to have the same answer as if you would to keep the I, but again, just a different method. We want to get rid of that square root here, so we're going to first move the 3 over. So that's x minus 3 is equal to negative 2 times the square root of negative 1. I'm not going to move the 2 over because I want to keep it and not work with a fraction, because why would I want to work with fractions? Square both sides to get rid of that radical. That x minus 3 squared is a perfect square trinomial, so it FOILs out to be x squared minus 6x plus 9 is equal to, the negative 2 squared is 4, the square root of negative 1 squared is just negative 1. That 4 times negative 1 gives you x squared minus 6x plus 9 is equal to negative 4. You can't leave that negative 4 there. It's got to be equal to 0, so move the 4 over by adding it to both sides. This gives you x squared minus 6x plus 13 is equal to 0. That is what you are going to use in order to do your long division with that g of x polynomial. So you're going to put the x squared minus 6x plus 13 on the outside. On the inside, we're going to put that x cubed minus 11x squared plus 43x minus 65. We're going to use our long division. So x squared times x gives us x cubed. The x times x squared is x cubed. X times negative 6x is negative 6x squared. And x times 13 is 13x. We subtract these, distribute the negative, change the sign on everything inside. Those x cubes cancel. Negative 11x squared plus 6x squared is negative 5x squared. And 43x minus 13x is 20x. You have 4 terms on the outside, or sorry, 3 terms on the outside, only 2 that you're working with on the inside right now. So bring down that negative 65. Now you have 3 terms on both parts. It is not, yes, it is 30. Why did I put 20? This is 30. Thank you. So now work with this. You have 3 terms on the outside, 3 terms underneath. The x squared times negative 5 is negative 5x squared. That negative 5 times negative 6 is positive 30x. And then the negative 5 times 13 is negative 65. Subtract these, distribute your negative, change the sign on everything inside. The 5x squareds cancel, the 30x's cancel, the 65's cancel to give you 0 as a remainder. So now you take that x minus 5, set it equal to 0, and solve. Move your 5 over, add it to both sides, and you get x is equal to 5. So look at your zeros or your solutions. You're supposed to have 3 answers, yes. How many do you have right now, though? You have that x is equal to 5, and you have that x is equal to 3 minus 2i. Where's the other one? It's a positive 2i. It's the conjugate of that 3 minus 2i. So when you go to give your answers, you got to include the x is equal to 3 minus 2i, as well as its conjugate of x is equal to 3 plus 2i, as well as x is equal to 5. For 3 and 4, it tells you to write the polynomial with the given zeros. For number 3, it gives you x is equal to 3 and x is equal to 7i. If we work with the square root of negative 1 here, we're going to change the I to be the square root of negative 1. So really, this is going to give us x is equal to 7 times the square root of negative 1. That x is equal to 3 is simple. Move the 3 over by subtracting it from both sides. You get x minus 3 is equal to 0. However, the x is equal to 7 times the square root of negative 1. You do not want to work with that square root of negative 1. So square both sides. That gives you x squared is equal to 49 times negative 1. That 49 times negative 1 is negative 49. So x squared is equal to negative 49. Move the 49 over to get it set equal to 0. Add it to both sides. And you have x squared plus 49 is equal to 0. So now you are multiplying x minus 3 times x squared plus 49. Your x times x squared is x cubed. X times 49 is 49x. Negative 3 times x is negative 3 times x squared is negative 3x squared. And negative 3 times 49 is negative 1. Okay, let's do it this way. 3 times 9 is 27. Carry the 2. 3 times 4. Yep, 147. Okay. From here, put it in standard form. So you have x cubed minus 3x squared plus 49x minus 147. For number 4, we are given that x is equal to negative 2 and x is equal to negative 5 minus 4i. Since we worked with the square root of negative 1 in number 3, I'm going to work with the I on this one. Okay, so the x is equal to negative 2. Easy. Move the 2 over, add it to both sides. You get x plus 2 is equal to 0. Perfect. However, the x is equal to negative 5 minus 4i. The I is an imaginary number, which means you have a conjugate with it. The conjugate of that, remember, keep the terms, change the sign between them. That's negative 5 plus 4i. So you got to work with both of those. If we move the 5 over, we add it to both sides. That gives us x plus 5 is equal to negative 4i. You also have to move the 4i over, so we add it to both sides with that first one. We get x plus 5 plus 4i is equal to 0. From here, we are going to work with the x is equal to negative 5 plus 4i. Move your 5 over like you did on the other. Add it to both sides. You have x plus 5 is equal to 4i. From here, subtract your 4i over. And that's x plus 5 minus 4i is equal to 0. Now you have 3 parts here that you need to multiply together. You have x plus 2 times x plus 5 plus 4i times x plus 5 minus 4i. So I'm going to start this one by multiplying the last 2 sets of parentheses. That x plus 2 stays. Then we have x times x, which is x squared, x times 5, which is positive 5x, x times negative 4i is negative 4ix. The 5 times x is 5x, 5 times 5 is 25, 5 times negative 4i is negative 20ix. Next, nope, it's not ix, it's just negative 20i, sorry. Now the 4i times x is positive 4ix. The 4i times 5 is positive 20i. The 4i times negative 4i is negative 16i squared. We are going to combine like terms and simplify here. We know that I squared is equal to what? Negative 1. So we're going to multiply the negative 1 times the negative 16, which makes it a positive 16. Get rid of the I squared. Now look at your like terms. You have a negative 4ix and a positive 4ix, which are opposites, so they're going to cancel. You also have a negative 20i and a positive 20i. Those are opposites, so they cancel. So now you're only combining real numbers and real terms. You have x plus 2 that starts you off. Then you have x squared plus 5x plus 5x, which is 10x. Then you have the 25 and the 16, which is 41. From here, you just continue to multiply and combine like terms. So starting with the x times x squared, that's x cubed. X times 10x is 10x squared. X times 41 is 41x. Then 2 times x squared is 2x squared. 2 times 10x is 20x. And 2 times 41 is 82. Combine your like terms here and then you're done. You have x cubed, 10x squared, plus 2x squared is 12x squared. 41x plus 20x is 61x. And you drop down that 82. All of your like terms are combined, so that is your answer. For the next set of questions, you are asked to find the vertical, horizontal, slant asymptotes, and the domain. For these, remember with the domain, you're taking the denominator, setting it not equal to 0, solving, and writing your answer in interval notation. For your vertical asymptotes, take the denominator, set it equal to 0, and solve. So similar to your domain. Horizontal asymptotes, compare the numerator's degree with the denominator's degree. If the numerator degree is greater than the denominator degree, your horizontal asymptote is none. If they're equal to one another, take the leading coefficient from the numerator, put it over the leading coefficient of the denominator, and simplify. You're going to set it equal to y. Then if your numerator degree is less than the denominator degree, automatically it's y is equal to 0. Lastly, for your slant asymptotes, you are dividing your numerator by your denominator. So your denominator is going to go outside, numerator goes inside. That's also y is equal to, because you get rid of your remainder with your slant asymptote. For number 5, you're given g of x is equal to 12 plus 3x over 5x plus 2. I'm going to rewrite that numerator as 3x plus 12, just so that way it's in standard form. And if I have to compare my numerator leading coefficient to my denominator leading coefficient, I know what it is. So, starting with our domain. Take the denominator, in this case it's the 5x plus 2, set it not equal to 0, and solve. Move your 2 over, subtract it from both sides. You have 5x is not equal to negative 2. Then divide each side by the 5. You have x cannot equal negative 2/5. You're putting this into interval notation. So that means you're going from negative infinity to negative 2/5 with a union from negative 2/5 to positive infinity. Next, you look at vertical asymptotes. Vertical asymptotes, take the denominator, that's the 5x plus 2, set it equal to 0, and solve. Well, we kind of did this with finding our domain. We found that x was not equal to negative 2/5, so with this one, x is equal to negative 2/5. For your horizontal asymptote, you're comparing the numerator degree, which is 1, with the denominator's degree, which is 1. They are the same, so we are going to take the numerator's leading coefficient, put it over the denominator's leading coefficient. The numerator's leading coefficient is 3, denominator's is 5. That means that y is equal to 3/5 for your horizontal asymptote. For your slant asymptote, you would take the denominator, put it on the outside. That would be 5x plus 2. On the inside, you'd put the numerator. That's the 3x plus 12. The only thing that you would be able to do here is multiply that 5 by 3/5 in order to make it a 3x. So that would be giving you your horizontal asymptote. So automatically your slant asymptote is none. For number 6, you are given h of x is equal to x squared over x plus 2. So to start, we're going to find our domain. We take the x plus 2, set it not equal to 0, and solve. Move your 2 over, subtract it from each side. You get x cannot equal negative 2. That means in interval notation, you're going from negative infinity to negative 2, with a union from negative 2 to infinity. For your vertical asymptote, use your denominator. That's x plus 2 is equal to 0. We found that x is not equal to negative 2, so that means for your vertical asymptote, x is equal to 2. For your horizontal asymptote, we're going to compare the numerator degree to the denominator degree. Numerator's degree is 2, denominator's degree is 1. 2 is greater than 1, so we are going to take the numerator's leading coefficient. Or sorry, no, it's greater than, not equal to. It's greater than, so automatically our horizontal asymptote is what? None. This should be a negative 2. There you go. Thank you. Lastly, you are going to find your slant asymptote. To find your slant asymptote, you are going to divide, put the x plus 2 on the outside, the x squared plus 0x plus 0 on the inside. Remember, when you're doing long division, you have to make sure you have every power from highest to lowest. Your highest power on the top is 2, so you need to represent the x to the power of 1 and the constant, which means it's 0x and 0. Your x times x gives you x squared, so x times x is x squared. X times 2 is 2x. Subtract these, distribute the negative, change the sign on everything. That gives you negative 2x, and bring down the next term, which is 0. That x times negative 2 is negative 2x. Negative 2 times 2 is negative 4. You subtract these, distribute your negative, change your signs, combine like terms, you have a remainder of 4. Don't worry about the remainder. The only thing you need is the x minus 2. Set it equal to y, and that is your slant asymptote. For number 7, you have f of x is equal to x over x squared minus 25. For this one, your domain, you're going to take the x squared minus 25, set it not equal to 0, and solve. Move the 25 over, add it to both sides, or you could factor this since it's a difference of squares. It's up to you. You get x squared is not equal to 25. Take the square root of both sides. You have x cannot equal plus or minus 5. So the interval notation for your domain on this one is from negative infinity to negative 5, with a union from negative 5 to positive 5, with a union from 5 to infinity. Your vertical asymptotes. Take the x squared minus 25, set it equal to 0, and solve. That gives you that x is equal to plus or minus 5. Next, we find your horizontal asymptotes. For your horizontal asymptotes, compare your numerator's degree, which is 1, to your denominator's degree, which is 2. 1 is less than 2, so automatically your horizontal asymptote is y is equal to 0. if you were to try to divide for this, for your slant asymptote, you can't divide x squared into x kind of thing. So I said that wrong. You can't divide x by x squared. So you would not be able to do that. That means that your slant asymptote would be none. For number 8, you're finding the vertical and slant asymptote as well as the x and y intercepts. You're given h of x is equal to x squared plus 7x plus 10 over x plus 3. To find your vertical asymptote, take your denominator, which is x plus 3, set it equal to 0, and solve. That gives you that x is equal to negative 3. For your slant asymptote, you are going to divide these two. The x plus 3 goes on the outside. X squared plus 7x plus 10 goes on the inside. Your x times x is x squared, so that's x squared plus 3x. We subtract these, distribute the negative, change the sign on everything. You're left with 4x. Bring down that 10 and start all over again. The x times 4 is 4x. The 4 times 3 is 12. Subtract, distribute your sign. You're left with negative 2. Again, with your slant asymptote, the only thing that matters is the top part, which is that x plus 4. So set it equal to y, and you have y is equal to x plus 4. For your x-intercept, your y is equal to 0. So that means you have x squared plus 7x plus 10 is equal to 0. This factors to give you x plus 2 times x plus 5 is equal to 0. You set each part equal to 0 and you solve. And you get that x is equal to negative 2 and x is equal to negative 5. So those x-intercepts are the ordered pairs, negative 2, 0, and negative 5, 0. For your y-intercepts, you are plugging in 0 for x. Oops. Y-intercept. Plug in 0 for x. So that's going to give you y is equal to 0 squared plus 7 times 0 plus 10 all over 0 plus 3. Your 0 squared cancels, so does your 7 times 0 to leave you with 10 over 3. So if y is equal to 10 over 3, that's the ordered pair 0, 10 thirds for your y-intercept. For our next one, it tells us to find the domain in interval notation, vertical asymptote, horizontal asymptote, slant asymptote, x and y intercepts, and the holes. So with this one, everything's being brought together. So for the first one, number 9, we have x over, or f of x is equal to x over x squared minus 3x minus 4. To find our domain, we're going to take the x squared minus 3x minus 4, set it not equal to 0, and solve. We have x minus 4 times x plus 1 is not equal to 0. That means x cannot equal 4, and x cannot equal negative 1. So the interval notation on this is going to be negative infinity to negative 1, with a union from negative 1 to 4, with a union from 4 to infinity. For our vertical asymptote, we're going to take the same exact thing, but set it equal to 0. So x squared minus 3x minus 4 is equal to 0. We factored that to be x minus 4 times x plus 1, which means x is equal to 4 and x is equal to negative 1. For your horizontal asymptote, we're going to compare the numerator degree, which is 1, with the denominator degree, which is 2. 1 is less than 2, so automatically that's y is equal to 0. For your slant asymptote, we're going to divide. You cannot divide this, so that's just none. And then with your holes, we're going to factor. We have x over x minus 4 times x plus 1. Nothing would cancel out, so that means that we have none for our holes as well. For number 10, we have g of x is equal to x squared or 2x squared over x squared minus 25. So for our domain on this one, we're going to have x squared minus 25 is not equal to 0. Move your 25 over by adding it to both sides. That's x squared is not equal to 25. That gives you x is not equal to plus or minus 5. So for your domain, that's negative infinity to negative 5 with a union from negative 5 to 5 with a union from 5 to infinity. I just realized that I did not find our x and y intercepts for number 9, so I'll go back to that and find that as soon as I'm done with number 10. So for this vertical asymptote, we would have x is equal to plus or minus 5. Then for our horizontal asymptote, we compare numerator degree, which is 2, with denominator's degree, which is 2. 2 is equal to 2, so we're going to take the numerator's leading coefficient, which is 2, over the denominator's leading coefficient, which is 1. That gives us y is equal to 2. For your slant asymptote, you would divide. You'd have x squared plus 0x minus 25 over, on the outside, and then 2x squared plus 0x plus 0 on the inside. You can multiply by 2 to give yourself 2x squared. However, that's not giving you an x, so this would be none for your slant asymptote. So y is equal to 2 is already your horizontal asymptote, which is why we automatically say none for our slant asymptote. For our holes, we would also have none because you cannot factor anything from the top and cancel anything out. Next, we find our x and y intercepts. X-intercepts set y equal to 0, so that's going to be 2x squared is equal to 0. That gives you x squared is equal to 0, which means x is equal to 0. That's the ordered pair 0, 0. Your y-intercepts are going to be the same things. So y-intercept, your x is equal to 0, so that's 2 times 0 squared over 0 squared minus 25. That's 0 over negative 25, which is just 0. So that's the ordered pair 0, 0. Again, we said that we failed to do the x and y intercepts from number 9, so we're going to look at that and do that first. So your x-intercept for this one, your y is 0. That would give you y is equal to x. 0 is equal to x. So 0 is equal to x, which means that's 0, 0. For your y-intercept, your 0 is going to go in for x. So that's 0 over, it's going to give you negative 4, which would mean that's 0, 0 as well. Now, if we look at 11, we have h of x is equal to x squared minus x minus 12 over x squared minus 9. To find our domain, we take the x squared minus 9, set it not equal to 0. You move your 9 over by adding it to both sides. You get x squared is not equal to 9. And take the square root of both sides, that's x is not equal to plus or minus 3. So the interval notation on that is going to be from negative infinity to negative 3, with a union from negative 3 to 3, with a union from 3 to positive infinity. The vertical asymptote, same thing, but equal to, so x is equal to plus or minus 3. Horizontal asymptote, your numerator degree is equal to 2, denominator's degree is equal to 2. They are equal to one another. So that means we're going to take the leading coefficient of the numerator, put it over the leading coefficient of the denominator. They're both 1, so that's y is equal to 1 over 1, or just 1. For your slant asymptote, you are going to take the numerator and then divide it by your denominator. If you do that, it would just give you y is equal to 1, so that's none as well. Then for your holes, you are factoring, so you would have x minus 4 times x plus 3 over x minus 3 times x plus 3. The same thing that's on the top and the bottom is the x plus 3. So we set it equal to 0 and solve, and we get a whole at x is equal to -3. For your x-intercept, you're plugging in 0 for y, so that's going to give you x squared minus x plus 12 is equal to 0. So that factors to give you x minus 4 times x plus 3 is equal to 0, which gives you x is equal to 4 and x is equal to -3. So your x-intercept ordered pairs are the ordered pairs 4, 0 and -3, 0. For your y-intercept, you plug in 0 for x and you solve. So that's going to leave you with 12 over -9 because your x squared and your negative x up top cancel. Your x squared on the bottom cancels. So that gives you y is equal to -4/3. And that's the ordered pair 0, -4/3. For your last one, number 12, you have p of x is equal to 3x squared plus 5x minus 2 over x minus 2. For your domain, your x minus 2 is not equal to 0. X cannot equal 2, so that means you're going from -infinity to 2 with a union from 2 to infinity. Your vertical asymptote is just x is equal to 2. You get that from your domain. Your horizontal asymptote, you have a degree of 2 on the top, so numerator degree is 2, denominator's degree is 1. 2 is greater than 1, so that is none. Next, you are finding your slant asymptote. So x minus 2 goes on the outside. 3x squared plus 5x minus 2 goes on the inside. You are going to multiply this by 3x to get 3x squared. Then 3x times -2 is -6x. Subtract these, distribute your sign. The 3x squareds cancel. You have 5x plus 6x, which is 11x. Drop down that -2, then start all over again. Put your 11 up top, multiply that by x minus 2. You get 11x minus 22. Subtract these, distribute the sign, and you're left with 20. 20 doesn't matter. What matters is the 3x plus 11. So your slant asymptote is y is equal to 3x plus 11. Next, you find your holes. You are going to factor the numerator and the denominator here. This numerator, you have 3 and -2. So 3 times -2 is -6. Your factors of -6 that add to be 5 are 6 and -1. So we're going to rewrite this as 3x squared plus 6x minus x minus 2. And factor this by grouping. We factor out a 3x and a -1 to give ourselves 3x minus 1 times 2, x plus 2, all over x minus 2. Now this does not have anything that is the same on the top and the bottom, so our holes are none. Lastly, we find our x and our y intercepts. So x-intercepts, let's put this up here. Our y is 0, so we're going to have 3x squared plus 5x minus 2 is equal to 0. Because remember, we forget about that denominator. It factored to be 3x minus 1 times x plus 2 is equal to 0. So from here, and we know that from our holes, and from here we're going to have that x is equal to 1/3 and x is equal to -2. So our x-intercepts are the ordered pairs 1/3, 0 and -2, 0. Oops. And lastly, our y-intercepts, when x is equal to 0. These are when y is equal to 0 for x-intercepts. But for y-intercepts, x is equal to 0. We are going to have 3 times 0 squared plus 5 times 0 minus 2 all over 0 minus 2. Cancels, cancels, cancels. We have -2 over 2, which is positive 1. So that means that our y-intercept is the ordered pair 0, 1. Your quiz on these two sections is 7 questions long. Anything on your review is fair game to be on your quiz.